Getting started with Mistral 2023. Altair Mistral is our real-time monitoring solution that collects I/O, CPU, and memory metrics across your HPC estate. The I/O profiling data that you get from Mistral is really unique and cannot be collected by any other tool. You get per job and per file system metrics that are system and storage agnostic. Mistral lets you find noisy neighbors, that is bad jobs that overload shared file system. It also lets you understand how your applications are using your storage so that you can make decisions about the future or migrate to the cloud more easily. Let's see Mistral in action. Here I have a small PBS demo cluster and I've got a script that is going to submit 10 jobs. These are 5 different jobs in a loop of 2 and they're going to run across the 10 slots that I have in my cluster. This demo is with PBS, but it could equally be done with Altair Accelerator, Altair Grid Engine, or with third-party workload managers such as Slurm or LSF. Mistral can, of course, also be run on systems without a workload manager. I've now submitted those jobs. Mistral has been configured to send data to an Elasticsearch database. Let's look at the dashboard to see the data. This is the Mistral overview dashboard. It's showing me live data from those 10 jobs. At the top, we had file system reads and writes. This is the throughput per mount point and per job. Underneath, we have the total amount of data that has been transferred, again, per job and per mount point, as well as additional information about the file system type. We also track metadata. Here you can see for each mount point, the number of creates, deletes, access or file system changes such as move or chmod. And down at the bottom, we have the CPU and memory for that job. And we also have information about the host CPU utilization, so you can see what's going on that machine. This dashboard is great for finding those noisy neighbors that might be overloading your shared storage. By default, this dashboard will show the top 20 jobs by I/O. Of course, this is just a Grafana dashboard, so you can configure or add in additional filters, whatever you need. It'll also let you set up alerts, so if the I/O goes over a certain level, you can be alerted to that event. Mistral also monitors the I/O performance of the file system. So here in this dashboard, we look at the maximum call duration for metadata I/O. So what was the maximum time it spent to return from a particular call? Here it looks like we're maxing out at around 30 to 40 microseconds. We also have further down the maximum call duration for reads and writes. This is separated into small, medium and large reads and writes. We also have a dashboard showing network I/O. So this is tracking the read and write activity across the network, profiling, for example, MPI jobs. And for zooming in on a particular job in detail, we have 2 dashboards for that. This job I/O detail shows you the information over time. This shows the I/O in more detail than you see in the overview dashboard. So again, having the data split into small, medium and large writes. And we also have a brand new dashboard for this version, which is the job I/O summary. This shows you the I/O per job summarized at the end once the job has completed. We can look at the maximum CPU usage. So this is the maximum number of CPUs that job required. The total amount of CPU time. Of course, if you're using more than one CPU in the job, that could be longer than wall clock. We also have the maximum RSS memory and the maximum virtual memory. This is really useful for ascertaining whether a job actually used the resources that it requested. And we also look at the quality of the I/O. So here we look at the absolute I/O time per job split into good, medium and bad. Bad I/O is things like small reads and writes, failed I/O. We also have the ratio of good to bad I/O. So the chart on the left is great for finding those jobs that are overloading shared storage with lots of bad I/O. Of course, it might not be a single large job that's causing you problems. It might be lots of smaller jobs, in which case this chart on the right, you want to look at the jobs that mostly are bad IO. And of course, if you have lots of that job type, then that's something that you would need to investigate. As I scroll down the page, we also have that information summarized in tables. And then down at the bottom, we have the same charts, but these are operation counts rather than time spent in IO. So here you see often a different profile, because sometimes the bad IO is faster or significantly slower than the good IO. And so it's good to look at both the amount of time spent in IO as well as the operation counts. This is because on a healthy system, all IO should return relatively quickly. On a system that has been overloaded by lots of IO, then the time spent to return these bad operations will increase dramatically, and then that's when you'll see the profile of your jobs change. To catch that ahead of time, you want to look for the jobs doing large numbers of bad IO calls. In this case, this job only does 200,000 bad IOs, which is just fine. But when that starts creeping into the millions, that's when you want to start to investigate. Equally here, we have the same data, but instead of an absolute value, we have the ratio of good to bad. So we've seen so far how Mistral can be used to find noisy neighbours, and we've also seen how Mistral can be used to profile your applications in detail. Let's take a quick look at how Mistral is installed and configured. Mistral comes with a great quick start guide that will take you through step by step how to install Mistral and get it configured to log data to an Elasticsearch database and how to view the results in Grafana. We do support other data pipelines. We support InfluxDB as well, for example, but Elasticsearch is the better supported platform. This guide will take you through an introduction to the product, how to install Mistral. We now have new Docker Compose scripts to help you quickly install Elasticsearch and Grafana. And finally, if you do have any issues, normally there is some typo in one of your config files, this troubleshooting guide will take you through a step-by-step in order to find out where the error lies. So looking at the packages that you get with Mistral, the main config file is this Mistral config.yaml. All of the settings here are documented in the file. For most people, the default settings will be appropriate. Down at the bottom of this file, we have the plugin configuration. This is how you configure Mistral to talk to an external database. As you can see, we have the default settings for Mistral Elasticsearch. Mistral comes with a number of plugins. We support Elasticsearch, FluentBit, Splunk, and InfluxDB. We also publish the API should you wish to write your own plugin to push data to a different dashboard. Normally, Mistral is integrated with your workload manager. We provide integrations with the Altair workload managers, that's PBS, both Open PBS and PBS Professional, Altair Grid Engine, Altair Accelerator. We also integrate with Altair Flow Tracer, our workflow manager tool, as well as third-party workload managers such as Slurm and LSF. It's in this samples directory that you will also find the dashboards for Elasticsearch and for InfluxDB and Splunk. For information about how to integrate with each of the workload managers, please see the user guide under Scheduler Installation. Thank you for listening.